Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will show you how to use Excel for computations associated with binomial distribution. So I assume you've done a little bit of reading and you understand the basic definition of binomial and what to look for when it comes to identifying binomial problems. And now we're just going to focus on computations with Excel. So I will use one of the homework problems in your online assignment, and you might have slightly different numbers, but the idea will be the same. So this is problem 7 in section 5.2. Okay, let's take a look. Let's see what it says. We have a hotel claim that 90% of their customers are very satisfied with service. And we want to answer all of these questions. So before I answer each question, I'm actually going to run through the commands and fill out this entire table. Okay, let's see. My binomial experiment consists of asking 8 people, so that's my sample size, whether they're satisfied with the service or not. And the probability of one customer being satisfied is 0.9. And in this case, we consider a success if a customer is very satisfied. Okay, so if we survey 8 people, then the number of successes, meaning the number of people who said they were satisfied, will run through from 0 to 8. Okay, and you should have some sort of intuition associated with probabilities of each value, right? So you say, okay, the probability of one success is 0.9. So that's really high, which means we probably should have a lot more than 0, 1, or 2 people who are satisfied with this hotel. Okay, let's go ahead and compute these probabilities. So to compute probability of each value, we're going to do binomial dot distribution. Okay, and the syntax goes number of successes, so we'll start with 0, trials 8, probability of success on one trial is 0.9, and in this case we're not doing cumulative. Okay, so we're going to say either false, you can type in false, or just say 0, close the parentheses, and your intuition is probably telling you that this will be a small probability, and it is. Okay, so this is in scientific notation for a small number, e to the negative 0.8, that's just 8 decimal places to the left. Okay, so that's a small probability. Now you can type in all of these one at a time. Okay, so I'm going to do one more. So one success out of 8, probability of one success is 0.9, and 0 or false here. Okay, once again, this is a small number, or you can just drag this down and change one value in each row. So over here, I'm going to change this 1 to 2. Now I have 2 people who are satisfied, still small. Okay, now I'm changing this to 3, and so forth. So I'm going to change each one of these functions just one value, okay, the number of successes. We'll go to 5, next one 6, and you see how probabilities increase, which makes sense. Probability of one satisfied customer is pretty high. Okay, so now we get close to the end. Okay, so that's the probability of each of the variable x taking each value from 0 to 8. We can check that the total sum of these probabilities adds up to 1. Okay, so this is how you would compute probability of x is equal to exactly a value. Now, what about computing probabilities of an event where x is in between some values, right? So some range. So the function that's built in Excel will compute probabilities from 0 up to whatever number that you're going to use. Okay, and the first one will be exactly the same since there's nothing else to add up here, just 0, right? So we have the same setup, 0.08. Probability of success is 0.9. Cumulative, in this case, we're going to say yes or true. Okay, 1 for true. And the numbers are not different. Okay, but it makes sense because there's nothing else that can happen before x is equal to 0. Now over here, I'm going to go ahead and drag this down. Okay, I'm going to start changing that first input. Okay, so probability of what? This probability represents probability of getting either 0 successes or 1. Still pretty small, but now it's slightly different. Okay, this one right here represents the probability of getting 0, 1, or 2. Okay, 0, 1, or 2, or 3. And you can see how these probabilities are growing, which makes sense because you're adding up all probabilities above. Okay, 4, 5, 6, and you can probably see where we're going with this. At the end, we should get a probability of 1, okay, because we're adding everything up. So this would be at most 8, and you get 1. Okay, so what do these probabilities represent? Okay, think about these events as at most. Okay, these events are exactly X successes. Okay, all right, so now we can answer all those questions. Okay, so let's go back here. Let's see. What is the probability that exactly 7 customers are very satisfied? Okay, exactly 7. That's this column right here. So 0.3826. Okay, 4 decimal places, 0.3826. Let's check the answer. Looks good. Okay. Next question, what is the probability that more than 7 customers are very satisfied? What does more than 7 mean? More than 7 means 8, right? Okay, so more than 7 in this case, it's just 8, so we're going to copy this probability, 0.4305. Okay. Next is, what is the probability then less than 6 customers are very satisfied? Less than 6, it's 0 through 5. Okay, but not this one. This is exactly 5, right? Less than 6, so it's anywhere between 0 and 5 customers that are satisfied, so we're going to use cumulative, so 0.0381. Okay, so far so good. And the last question says the following. Suppose that 8 of customers selected who responded that they're very satisfied. What conclusion can be drawn about the sample? The probability that 2 out of 8 customers are very satisfied is small, so this would be, let's see, 0.00. Oops, that's the wrong 0. Okay, let me take a look. What is this? 5 zeros, so 4 zeros in front, 2. Okay, that is very unlikely to happen, so that is not likely that randomly selecting 8 customers would result in 2 responding and they were very satisfied. What do you not like? So do you want to put a 0 in there? Okay, round to 4 decimal places, so I guess that's 0. Okay, fine, so they want that. Okay. All right. Yep. So it's a very, very small chance. Okay. It's not going to happen. I remember well, it can happen, but it's really, really tiny. Okay. Remember our cutoff value is 0.05. Okay. So with this problem, we're done. Let's see what else I could ask you about this particular problem. I could ask you something like, what is the probability? Let me type it up first. So at least 5 successes. Right? At least 5 customers that are satisfied. Now, at least 5, notation-wise, this is probability that X is greater than or equal to 5. Okay? So, if you have this table set up, you say, okay, I'm just gonna add up these values right here, and you could do this. So there's a couple of different ways we can do it. So let's do it with the table. Okay. So summation of what? At least 5. So it's 5, 6, or 7 successes. Okay. Pretty high chance. Or we could use the complement rule and say probability that x is greater than or equal to 5. Okay. It is equal to 1 minus the probability that x is less than or equal to 4, okay? Which is, we've computed, it's this value right here. This is less than or equal to 4. And look, it's exactly the same thing, okay? So this way right here is useful when you don't have the entire table worked out, right? So for example, what if you have your values of x go from 0 to 50, okay? Are you going to make this table every time? Well, maybe not. So you could always compute these probabilities, remembering the complement rule. 1 minus the complement. So let me type it out here. This is 1 minus the probability of x is less than or equal to 4. Okay? And that we already computed, or you can just type it in again using the binomial cumulative. All right. Okay. Thank you for watching.